Ever wondered how those deep excavations for skyscrapers and underground structures are made possible? How the basements are made in our malls and office building? How do the construction workers and engineers work so deep below the ground, the huge skyscrapers? Metro stations, subways, dams, tunnels, sealinks, but do you know what keeps them safe? The one element that keeps water out, soil from caving in and protects us. Well, stick around because we're about to uncover all the secrets. Hello, and welcome back to our channel. Today, we're diving deep into the fascinating world of construction with a focus on diaphragm walls. When it comes to deep construction work, one of the key elements to consider is the construction of diaphragm walls. These walls are essential for providing structural support and preventing water seepage in deep excavations. Did you know? Burj Khalifa, Dubai, UAE, the world's tallest building, Burj Khalifa, employed diaphragm walls during its construction to create a strong foundation for the towering structure. Taipei 101, Taipei, Taiwan. This iconic skyscraper, once the tallest building in the world, utilized diaphragm wall technology for its deep excavation and foundation work. Marina Bay Sands, Singapore. This integrated resort complex features 3 towers connected by a sky park, and diaphragm walls were used to create a stable foundation for the structures. International Commerce Center, ICC, Hong Kong, ICC. One of Hong Kong's tallest buildings utilized diaphragm walls for its deep excavation work, ensuring stability during construction and beyond. The Leadenhall Building, London, UK. Also known as the Cheesegrater, this distinctive skyscraper utilized diaphragm walls during its construction to support its deep foundation. The Shard of Glass, London, UK. Another prominent London landmark, the Shard, relied on diaphragm walls for its deep excavation and foundation work, enabling the construction of this iconic skyscraper. But first things first, what exactly are diaphragm walls? To put it in simple words, diaphragm walls are reinforced concrete walls constructed underground to support deep excavations. They're often used in urban environments where space is limited and neighboring structures need to be protected. So, how are diaphragm walls made? Let me break it down for you. Diaphragm wall construction is a complex process that involves several stages. In this section, we will take a closer look at each stage of the process. Stage 1: Excavate a trench to the desired depth and width. This trench will serve as the guide for the placement of the diaphragm wall panels. A diaphragm wall can have a thickness ranging from 60 centimeters to 150 centimeters, and a width of 2 meters to 3.5 meters. The depth of a diaphragm wall can vary depending on the project requirements, but it can go up to 60 meters, sometimes even more. Establishing the correct position and alignment of the diaphragm wall, using surveying techniques and marking it on the ground. Since we are going below the ground, we can't see much, so we have to rely on various techniques. Guide walls are built on both sides of the planned excavation area. This is to ensure accurate trenching and support during diaphragm wall construction. Help to keep it straight as the running lengths of the wall are huge. Stage 3: Trenching. The process begins with excavating a narrow trench along the marked alignment to the desired depth and width for the diaphragm wall. This is done using specialized equipment called a trench cutter or a hydraulic clamshell grab. The trench is typically around 1 to 2 meters wide and can extend to great depths, sometimes reaching over 100 meters. This is followed by trench cleaning. Once the trench has been excavated, loose soil and debris are removed from it to create a clean surface for the next steps. A slurry wall is constructed in a trench that is filled with a fluid mixture, usually bentonite or polymer, that prevents the soil from collapsing. The fluid is later replaced by concrete that is poured from the bottom up using a tremie pipe. Stage 4: Reinforcement cage. Once the trench is excavated, steel reinforcement cages are lowered into the trench. These cages are crucial for providing strength and stability to the diaphragm wall and help prevent the walls from collapsing under the weight of the surrounding soil and groundwater pressure. Temporary stop ends are installed at the bottom of the trench to prevent concrete from flowing out during placement. After the concrete has cured sufficiently, the temporary stop ends are removed. A diaphragm wall is constructed in panels. Each can have a thickness ranging from 60 cm to 150 cm and a width of 2 meters to 3.5 meters. All the panels are slightly overlapped to ensure a tight seal between them. The sequence of filling this panel is doing the alternate panels and then filling the intermediate one. The last panel to be filled is called the closing panel. Stage 5: Concreting the wall. Next comes the concrete. High-quality concrete is poured into the trench using tremie pipes, which ensure a continuous flow of concrete from the bottom up. This prevents any voids or weak spots from forming in the walls. The bentonite or polymer fluid is pumped out slowly as the concrete replaces it. This is a highly coordinated action. As the concrete sets, the panels are joined together to form a continuous wall. This is done by overlapping the panels and ensuring a tight seal between them. The concrete wall acts as a barrier to water and soil pressure and can serve as a foundation or a structural element. Finally, the top of the diaphragm wall is capped off. This is done with a concrete beam to provide additional support and stability. The area behind the completed diaphragm wall is excavated and anchors or supports are installed if necessary for stability. After this, finally, stress is applied to the anchors and the final level of excavation is adjusted to ensure the desired structural integrity and ground stability for diaphragm wall construction. After the 9/11 attack on the World Trade Center, investigations were done on the tragic collapse of the structure. During this, it was understood that the Twin Towers did not topple immediately after being hit by the huge plane. It stood there strong for over an hour. The main reason was that the designers and engineers had used this ingenious method of diaphragm walls and ground anchors for its foundations. You can watch the entire videos on this on my YouTube channel, Behind Big Builds. It explains the structural secrets of the Twin Towers and amazing lessons to learn for architects and engineers. I think this has given you a fair idea of why diaphragm walls are needed. These walls play a crucial role in stabilizing deep excavations, preventing soil movement, and protecting adjacent structures from settlement or damage. One of the main advantages of diaphragm walls is their ability to withstand high lateral loads, making them ideal for projects in densely populated areas or areas with soft soil conditions. Additionally, their watertight construction helps control groundwater seepage, which is essential for underground structures like basements or tunnels. Engineers must take several precautions to ensure the walls are built safely and efficiently. These include proper soil analysis, groundwater management, and monitoring for any signs of instability during construction. But without this ingenious method, it would have been impossible to see the mega structures we see commonly around us in the last few decades. In conclusion, diaphragm walls are a vital component of modern construction projects. Their versatility, strength, and watertight properties make them an indispensable tool for engineers and developers around the world. And that's a wrap for today's video. We hope you enjoyed learning all about diaphragm walls. Don't forget to like, share, and subscribe for more fascinating insights into the world of construction. Until next time, stay curious and keep building.